Great. So now this is the last part of section 1.2. Now in this part we are going to study composition of functions. Let us say we are given two functions f of x and g of x. Then we are going to define a new operation called composition of functions in the following two ways. So this notation means g composition f of x, and this is defined like this. So we have g of f of x. The second operation is f composition g of x, and this means f of g of x. Okay. Now let us think about this first equation. So here my input to function g is f of x, but in the second equation the input of function f is our new function g of x. So in some sense the composition of functions indicates a function inside another function. Let us draw a picture. So let us say here we have our function f of x. Now if you think about this function f of x, its input is x and its output is f of x. Now in this first rule what we do is we input this output into the function g. Then you should get g of f of x. If you input x to g, then your output is g of x, but now your input is f of x. Therefore your output should be g of f of x. So this is g composition f of x. In the same way we can draw a diagram for this second composition, but now first we have our function g. So your input is x and your output is g of x. Next we consider this output and we input this one into the function f. Okay. Now your output should be f of g of x. So in this case your argument or the input should be g of x, and this is f composition g of x. So this symbol means composition. That is the notation for composition. So next we are going to consider an example that involves composition of two functions.